Okay, so on 8.2, that should be on the front of your packet if you found it yet. Okay. Okay. Thank you. Okay, so we're going to start with independent and dependent. Your notes look a little bit different than mine. It has all the same stuff. I just put it in a different order. So here's what you need to copy down. Independent are two events are independent if the probability of each event does not affect the outcome of the other event. Okay, two events are independent if the probability of each event does not affect the outcome of the other event. Okay. Our example is, does the probability of being left-handed affect the probability of it raining today? Not at all, right? They're not related at all. So those are both independent events. Can you print this out for me? This one. Okay, dependent events are two events are dependent if the probability of the first event affects the outcome of the probability of the second event. Okay. So again, two events are dependent if the probability of the first event affects the outcome of the probability of the second event. Here's that, just so you don't have to copy everything down. Okay, so this is the probability of me choosing a random student to go to the office, them leaving, then I choose another student to go to a different classroom for me. Me choosing the one person to leave to begin with will affect the probability of the second one because there'll be less students in the classroom to choose from. So those are dependent events. So this was no, and this is yes. You don't get it? Okay, are the following event scenarios independent or dependent? So if I roll a 2 on a number cube and then get heads when I flip a coin, are they independent or dependent? They're independent. It doesn't matter. Rolling the dice doesn't change how I flip a coin, right? So these are independent. Okay, if I have a bag of marbles that contains marbles of two colors, I put the marble aside and select a second one. So I pull one out and I put it aside and then I pull another one. Do they affect each other? Yes, because whatever I pull the first time is going to change. What I pull first is going to affect the outcome of the other one because there'll be less marbles in the bag. So these are dependent events. Any questions over that? Okay, so now go back to the top where you have, we're going to skip union. That's on your page. Skip union. Go down to intersections. Copy down the intersections. Okay, intersections of two sets is the set of elements that belong to both sets. Okay. So in our notes from right before lunch, when we were talking about math and science, taking math and science, what was the intersection of those two? The people who are taking both math and science. Okay. So that's this. The intersection is, okay, elements that belong to both sets. The example, the probability of me choosing a student from my class that is a junior and 16 years old. Notated as the probability of junior, upside down U, the intersection, probability of junior with the intersection of 16 years old. 1 second. So a student who is both. Does that make sense? This is a really big delay right now. Okay, I need you guys to cross out the complements. That's right there. Or if you wrote it there, that's fine. Okay, we need to put and in there. So if you can put and at the bottom of your page, down here. If you didn't write down the complements yet, cross out complements, put and there, and we can write complements down here. Does that make sense? Okay, wherever you have some room to write the word and the definition. No, because we need to come back. We need to have union. Don't cross off union. We need that. Okay, does that make sense? Okay, and is the probability of one, this should be one. One event occurring, then the probability of another event occurring. The probability of one event occurring, then the probability of another event occurring. So with an and, there's two events happening, two things happening. Okay, so it's the probability of me choosing a student from my class that is a junior. Then I choose another student and I want it to be a 16-year-old. It's notated the same way. The notation is still junior, but this is now and 16 years old. So the difference between the action and the word and is and has two events. Two people I'm picking, two marbles that I'm pulling, two coins that I'm flipping. Any questions over that? Okay, then once you have, if you haven't already, write down the complements as well. Complements of two probabilities whose sum is 1. Example, the probability probably of it raining tomorrow. Tomorrow's complement is the probability it won't rain tomorrow. The complement of raining tomorrow is not raining tomorrow. Because there's exactly 2 events, and that's the only options, right? Either it's going to rain or it's not going to rain. There's not another option in there. Any questions over that? We're good? Okay. So we've skipped union. We'll come back to union in a second. We want to focus on our and intersections. Okay, find the probability of the following events. A bag containing 6 red chips, 9 black chips, and 5 blue chips. 2 consecutive chips are drawn from the bag without replacement. Find the probability of each event. Okay, so the first one, C, is probability of blue and blue. Would this be an intersection or an and? How many events are happening? 2 events. Which one had 2 events, the and or the intersection? And is 2 events. Intersection is 1. Okay, it's me choosing a 16-year-old who is a junior. Okay, this is me choosing 2 different people, one that's a 16-year-old and one that's a junior. So I'm choosing 2 different things, so this is an and. Okay. Because it's an and problem, you multiply. Because it's an and problem, you multiply the probabilities. Okay, so our first step is to find the total. We have 6 plus 9 plus 5. How many is that? 20. In my bag. Okay. So the probability of the first thing is 20. And then how many are blue? 5 are blue. Then we're going to multiply it. Okay, so I've picked that chip. I've put it aside. Now how many chips are left in my bag? Now I have 19. So there are 19 chips left now on the second time. How many blue are left? There was 5. I picked one out, pulled it, put it aside. How many are left in there? 4. So now there are 4 blue chips left. Does that make sense? Okay, since it's an and problem, we're going to multiply. So we're just going to multiply straight across. So this would be 20 over 380. Then we're just going to divide that. So 20 divided by 380 is 0.052. I move my decimal over twice, and I get 5%. Any questions over that? We're all good? Okay, next one. The probability of black and red. Okay, so again, we're starting with all the chips in my bag now, so I have a total of 20 to begin with. Need to go back and find out how many black chips I have. There's 9 of them. Okay, once I pull the chip. Alyssa, how many chips do I have left in my bag now? No, how many total chips do I have left? 19. Okay. And then how many red ones do I have left? That was black chips. There was 9 black chips. So I have 8 black chips left. But how many red chips do I have? 6. I haven't pulled any red chips yet, so I still have 6 of them in there. So I have 54 over 380. So I do 54 divided by 380. So I have 0.142. Move my decimal over twice, and I get 14%. Any questions over that? Okay. This one has 3 events happening. So it's just going to be 3 different fractions that you're going to multiply. So everyone try that one. So my first probability was 20, and there were how many reds? 6. Now I only have 19 left. And my probability of blue, there were 5 blue. And since I haven't pulled a blue yet, I still have 5. Now I've pulled out a blue one. I only have 18 left in my bag. Okay, and I'm pulling a black, and there's 9 black left. Okay, I multiply it all together and divide, and I should have gotten 0.039. I move my decimal over twice and get 4%. About 4%. Any questions over that? We're all good? Yes.
Is there a difference between putting about 4% or equal to 4% or a different sign?
So the about is because we rounded. If it was exact number, you put equals. Now I'm not going to mark you down if you don't do the correct one, but that's the difference. Yes. Yes, it should tell you. If you put 3.9 in it because it didn't tell you, you'd still get it right. Okay. Any other questions over that? Okay, mutually exclusive and not mutually exclusive. Okay, 2 events. Mutually exclusive means 2 events that can't happen at the same time. There are 2 events that can't happen at the same time. So we're going to draw 2 circles here. Okay. And I want an example. Rolling an odd number or a 2. On a dice. Okay, can I roll a dice and get an odd number and a 2? If I just roll one? No. So these are mutually exclusive because I can either roll an odd number or I can roll a 2, but I can't roll a number that is both. Does that make sense? Okay. So what do we think not mutually exclusive would be? Very good. Okay, 2 events that can happen at the same time. Okay, 2 events that can happen at the same time. Okay, so this is like we did again, the people who could take math and science. Okay, there's going to have an overlap of the people taking both. So we draw our 2 circles. Oh, I just did that wrong. Undo. Sorry, let's try this again. We'll get it. We'll get it there, right? Okay. There we go. Whew, that was hard. So our example here would be rolling an even number or a multiple of 3 on a dice. Okay, so we can have this one that is an even number. And then this one would be a multiple of 3. What number do they share? Right? 6 is an even number and a multiple of 3. So 6 is that overlap. Any questions over that? So this is not mutually exclusive because it has an overlap. Any questions? Okay, unions. So go back to that front page where we skipped union. And here's what the definition of union is. Okay, union or. The union of 2 sets is all of the elements that belong to one or both sets. The union of 2 sets is all the elements that belong to one or both sets. Sorry, that's worded poorly. Okay, so it's the probability of me choosing a student for my class that is either a junior or 16. It is notated as the probability of junior, then a normal U, the union, and 16-year-old. It is one who is a junior or 16 or both. Any questions over that? Do we have this all copied down? We're good? Okay. So now let's go into the probability of our OR. A number cubed is rolled and the top face is recorded. Determine if the events are mutually exclusive or not mutually exclusive and find the probability of each event. So this is an OR problem because of that U that's facing up. Okay? Remember the one that faces down? The upside down U is an and you multiply. Or this time means we're going to add. Okay, so we're going to list all the things on our number cube. So 1, 2, 3, 4, 5, and 6. This is our sample space. All the possible outcomes. Okay, so the first one is a 1. The second thing I'm trying to find is a 4. I want a 1 or a 4. Okay, so underline the 1 and circle the other. Is there anything that is both? A 1 or a 4? Can I be a 1 and a 4 at the same time? Nope. Okay, so this is mutually exclusive. Okay. So our formula would be the probability of A or B is going to equal the probability of A plus the probability of B minus any of the overlap, which would be the probability of A and B. That's your formula. That's our formula for our OR problems. Any questions? Just need to memorize it. So what this means in regards to our problem now, it's the probability of 1 or 4 should equal the probability of choosing a 1 plus the probability of choosing a 4, subtracting the probability of me choosing 1 and 4. So how many 1s are on my number cube? 1. So there's a 1 out of 6 chance of me choosing a 1. Does that make sense? Nod your heads if you think so. Okay, if you're not sure, please ask. Okay, what's the probability of me choosing a 4? 1 out of 6 again. Does that make sense? And what was our probability of choosing a 1 and a 4 at the same time? 0, right? So there's no overlap. Okay, that's what that 0 over 6 means. There's nothing that's both of those at the same time. So this I just combine 1 plus 1 is 2 over 6, which is about 0.33. I move my decimal over with a line above it, right? It's going to be 0.333333. So this is 33%. Any questions over that? We're all good? Okay, next one. Okay, the probability number greater than 2 or 6. So I'm going to start with 1, 2, 3, 4, 5, 6. I want my sample space. I write it all out. I'm going to underline numbers that are greater than 2. So 3 is greater than 2, 4 is greater than 2, 5 is greater than 2, and 6 is greater than 2. And I'm going to circle all the numbers that are 6. Are there any numbers that are both? Yes. Okay, 6 is both. So that means, are these mutually exclusive or not mutually exclusive? Not mutually exclusive. Okay, because there's an overlap. So again, we're going to take the probability of me choosing a number greater than 2 plus the probability of me choosing 6. And then I have to subtract the probability of a number greater than 2 and 6. Does that make sense? Okay, Emily, what is the probability that I'm going to pull a number greater than 2? 4 out of 6. Very good. Jacob, what's the probability of me choosing a 6? 1 out of 6, right? There's only 1 6 on the number cube. Okay, and then what would be the probability? How many numbers are both? Okay, the 6 is both. So minus this guy here, 1 out of 6. So the probability of a number greater than 2 or a 6 would equal 4 plus 1 is 5, minus 1 is 4. So 4 out of 6, which is about 0.66 with a line above it. I move my decimal over twice, so that'll give me 67%. Any questions over that? We're all good? Okay. You guys do the next one. H. Okay, so again, we should be listing 1, 2, 3, 4, 5, and 6. So I'm going to underline the numbers that are less than 5. That'd be 4, 3, 2, and 1. So there are 1, 2, 3, 4 numbers that are less than 5. So 4 out of 6 is my probability. Then I'm going to circle a number that is even. So 2 is even, 4 is even, and 6 is an even number. Some of you guys forgot about 6. So that would be 3 out of 6 numbers that are even numbers on my number cube. Now I have to subtract the overlap, the ones that are both. 4 is both underlined and circled, and 2 is both underlined and circled. Okay, so I subtract 2 out of 6. That gives me 4 plus 3 is 7. 7 minus 2 is 5 out of 6. When I divide that, I get about 0.83. Move my decimal over to 83%. Any questions over that? We're all good? Okay, so the next ones are that A and B are mutually exclusive. Find the probability of A or B. A or B means adding. I'm adding here. Since they are mutually exclusive, that means there is no overlap, which means no subtraction. Okay, I only subtract the overlap. And since I don't have any overlap when they're mutually exclusive, I don't have to subtract. So we're finding the probability of A or B. Remember, or. It's an or problem, so you add. So I just take the probability of A plus the probability of B. So I'm going to have 30% plus 12% equals 42%. Pretty easy, right? All it's really testing you here is, do you know what that notation means? Do you know the probability of A or B means to add? Okay, J, I'd rather work with percentages, so I'm going to change this into percent. So 2 divided by 5 equals 0.4. I'm going to move my decimal over twice to get 40%. Then I'm going to do 1 divided by 6 to get 0.16 with a line above it. So I move my decimal over twice and get 17%. So then I just get 40% plus 17% equals 57%. Any questions over that? We're all good? Okay, K is the same type of deal, but I give 1% and 1 fraction. So I'm going to convert my fraction into a percent. .125. I'm going to move my decimal over twice. I'm going to get 12.5%. If you rounded it to 13, it wouldn't be bad, but since it ends at 5, it's easy just to leave the 0.5. So I'm going to do 24% plus 12.5% will equal 36.5%. Any questions over that? Okay, so your homework is 8.1 and 8.2.